Hey, Chem kids, we are finally ready to talk about how ionic bonds form. All right, here we go. That's our central question. How do these things form? And how do we know what the formula for an ionic compound will be? So we'll be able to put together, like, here's how they're coming together, and this is why this is the formula. Here we go. All right. In ionic bonds, electrons are transferred from one atom to another to allow the atoms to fulfill their life's mission of having a full valence shell. All right. So what we have here then, of course, are anions and cations. They are held together by their opposite charges. The cation gives an electron or two or three to a nonmetal. The nonmetal then becomes an anion. Now they have opposite charges, and it's those opposite charges that cause them to be attracted to each other. It causes them to stick. This is the bond. Okay, it has to do with their opposite charges. All right. Ionic compounds are called salts. Did you do a lab that involved some salts? I wonder if they were ionic compounds. Okay, so salts are actually crystalline solids. We call the ratio of the cation to the anion in an ionic compound the formula unit. We also just call it the formula, but we'll see why we kind of distinguish that. It's a little bit different than molecules. These are not molecules. Okay, they're actually multiple cations and anions stuck together. So we just look at what is the ratio, how many of the cation are there for every however many anions. All right, so salts are not molecules, and that's something that maybe you have not heard before. We've dumbed it down for you up to now, but now that you have made it to chemistry class in high school, we can clarify that salts are not actually molecules. We'll continue to talk more about that. All right. Ionic compounds are made up of a positive and a negative ion. Keep that in mind. Maybe, more than one of each of these. Okay. A cation and an anion are always involved. Also, you're always going to see ionic compounds made of a metal and a nonmetal. Please notice that this is three different ways of saying the same thing. Okay. Metals form cations. That's going to be your positive ion that's involved in the compound, and nonmetals form negative ions. Okay. So when you are trying to discern, given a formula, what type of bond that compound is going to have, look for compounds that contain a metal and a nonmetal. If you see both of those, then you are very, very likely to have an ionic compound. Now, there are some exceptions to that. We'll work on those later. We're going to keep it simple for now and see what these do. All right. So again, that smallest repeating unit of however many cations and however many anions is called the formula unit. We can also just call it the formula, but we want to recognize that there are going to be many, many of these in any given salt crystal. And it's the ratio, the smallest ratio, kind of like an empirical formula that we call the formula or the formula unit. All right. So you should have watched a video about Lewis dot structures. And if you look in the slides, this is actually a link to that video if you haven't seen it yet. Lewis dot structures are a model that we use to keep track of the valence electrons of any given element. So we just represent those valence electrons as dots around the symbol. So this X isn't really a chemical symbol, but that is the variable for whatever chemical you have there, and or element that you have there. And so we put the valence electrons as dots in pairs on each side. Okay, so you can have a pair on top, a pair on the side, a pair on the bottom, and a pair on the other side up to 8, which makes sense. That's the maximum number of valence electrons that an element can have. All right, and so you write the symbol, and then you put one dot for each valence electron, but don't pair them until you have to, until you have more than 4. If you have up to 4, you're going to put one on each side. And then as you are placing more than 4 valence electrons, that's when you put them in a pair, right? If you had 4 of them, then you would put a 5th next to one of those, and then a sixth next to the other. Okay, and this video has a really good description and explanation of that. Okay, so I'm going to let you go ahead and do these on your own. Try drawing the electron dot diagrams for each of these. They are on your reference table, not your reference table. They're on your guided notes. I will go ahead and point out, let's see. No, let's go back one. That the Lewis dot structure for helium only has 2 valence electrons. So we would actually do that like this. Okay, put them together to indicate that that is a complete valence shell for helium. All right, maybe I'll just try one with you though. For instance, sodium only has 1 valence electron, so we would just put 1 dot next to its symbol as the Lewis structure. Okay, this video is starting to get long. I think we need to move on to another one. We'll show how some of these things come together in the next video.